Hi, in this video I'll try to give you a general understanding and overview of Ethereum. This video is not just for investors, but I think anyone that is actually interested in the platform will benefit from it. But this is the first video out of a series about Ethereum for investors, and in the following videos I'll really go deep into the potential applications, the concrete cases and projects that you can invest on, and also different notions about value in Ethereum. But before we go into this, I think it's really important that you understand at least some of the underlying technology that's behind it. So I'll try not to go into too much technical details, but I will give you some of what you need to actually be able to make decisions by yourself. So the information is updated as of, let's say, November. By then, some of it might change, but I try to keep it extremely general and generic. So, for example, I won't talk about any particular application or any given project in this video. I really try to keep it general, and I will actually mention that with an asterisk that you see here. So that's really important, so that even in 1, 2, or 3 years you will still be able to watch this video, and that will really help you understand it. So let's move on. So to understand the basics of Ethereum, we'll actually have to take a look at Bitcoin first. And even if you're already familiar with Bitcoin, I'm sure you'll learn a few things, and it's not going to be too long. And then we'll go into some more technical details that is really useful. And it's actually quite fascinating. It will really give you a different look or outlook on what it is. So I think it's going to be very valuable to you, even if you're just interested in investing and you're not necessarily a developer. And if you are, then it's definitely something that you actually should know. And we'll talk about applications, as I said, in a pretty generic or general fashion, but it's still gonna be concrete applications, but I'm just not gonna mention any specific projects. So just a small disclaimer, I'm not a member of the Ethereum Foundation. And so let's just start. What is Ethereum? So if you were to actually look up on Google what Ethereum is, that's the kind of stuff you would end up finding. So bear with me. Ethereum is a cryptocurrency platform and Turing-complete programming framework intended to allow a network of peers to administer their own stateful, user-created smart contracts in the absence of central authority. And yeah, I mean, the first time you hear something like this, you must just be thinking like, wow, that's so complex, and there are buzzwords everywhere. And I'll try to give you an idea of every single keyword that's actually in this sentence, in this video. That's actually from Wikipedia. The next sentence is, it features a blockchain-based virtual machine. So you probably already have heard about the blockchain. That securely records and incentivizes the validation of transaction. So there is this idea of currency, cryptocurrency that we heard before, i.e. code executions made through a cryptocurrency called Ether. All right, so that's might be pretty hard to understand that the first time you hear that, but we'll understand it. Don't worry about it. So probably the first world computer, said one of the founding, or let's say important members of the foundation, global singleton, another buzzword. And as I mentioned, Ethereum has been largely inspired by Bitcoin. And because of all the technological improvements and ideas that it brings to the table, some have called it Bitcoin 2.0. So we'll need to talk about Bitcoin first. So Bitcoin is a decentralized payment system. So you all know what a payment system is. You probably already have used PayPal. That's a very good example. And or any credit card transfer is also very centralized, in the sense that if you want to pay for some good on the internet, you'll actually have to transfer that money to the merchant through a third party, and that third party is just one entity controlled by just one organization. The idea of decentralization is that there is no central node. So let's just look at this diagram. So on A, we actually see that this is a very centralized network or system, if you want. That's actually as centralized as it could be, because every single node is isolated and is only connected to the central point. So that's centralized. A decentralized network looks more like this. There can be some variations of how it can look, but this is the main idea, that nodes are also connected to other nodes. That is the idea of peer-to-peer. And although they might actually, let's say, interact over a common node or single point, there is no real single point of failure, since if any one of those, basically there's no real central node. It's just an illustration here. And so you see that it's much more difficult to control such a network. No single person has complete control over it. So that is a very important point, and we'll see why it's so useful and what it can actually help us create and manage in terms of applications. So trustless transactions. So the idea of trusts, of course, if you just want to buy some good on the internet and you have to go through PayPal, then obviously you need to trust PayPal. The idea of Bitcoin and the blockchain in general, we'll see what it is a bit just later, is that you don't really need to trust any one person in general. You just need to trust the network as a whole. And it actually uses fine game theory and economical incentives to make sure that every actor in the network actually will act in a desirable way. So we'll just look into it a bit later. So, and also what's really critical is the idea of distributed ledger. So a ledger is basically it's kind of a list of accounts really with balances. And if you think about your bank account, then, well, the amount of money you have in your bank account is actually decided by some numbers in the bank's computers, except the cash that you might have in a physical account, but really most of it is electrical as well. And the idea of Bitcoins is really to decentralize this process of accounting for money and putting it on a network that nobody controls, but that in which everyone participates. So as I said, this distributed ledger is what we call the blockchain. So conceptually, that's how it looks. It doesn't matter if you don't understand everything that I'm talking about. The idea is just that you kind of have this picture in mind. So if you take any block, let's say block 52, so there have been 51 blocks before it, and there will be blocks after it. The idea is that let's assume we are at block 52, so people are actually making transaction, and if you want to make a transaction, then you'll just talk to a node that's next to you. Let's just look at this. You might be here, and so you might just want to tell another node next to you that you want to transfer some of the cash that you have to some other address or person that you know, and you will just tell them, and the miners, we'll see what they are later, will include your transaction in a block. And after a given time, that is variable, but in Bitcoin it's, as of today, about 10 minutes on average, your transaction will be included in the block. The block will be, let's say, finalized, and a new one will be created. And the new one will actually refer back to that one. That's really important because it actually helps you make the network more secure, in the sense that if you actually wanted to invalidate block 51, then it would invalidate all the blocks before. So in a sense, it creates consensus, because there is some kind of dependency between blocks, and the earlier blocks are actually, in some sense, the parents of the later blocks, so no one in the later blocks has an incentive to change them. But I've cut a few corners here, but let's just keep it at there. And how it works really, in order to understand how it works, we need to look at proof of work and the use of computational power to make reverting a crypto challenge very difficult. But it doesn't matter. I just want you to actually have heard of those words, since you might need to, if you were to read an article about this, you need to have heard of those words, even if you don't necessarily understand all the technical details. So some say it was the first cryptocurrency. Ripple also was invented maybe before, but it's quite different. Bitcoin reintroduces a truly groundbreaking idea, and it was invented around 2009. So Bitcoin is not really fiat money in the strictest sense, because, well, first, it's not issued by a central bank, but also the supply of Bitcoins is fixed. So this is something that's really special. So there's no way for any single actor to just print money. But Bitcoins can be mined, but the total supply of Bitcoins is finite. So we'll look into it later, but as an investor, obviously that's something that you should know about. And although some might disagree, Bitcoin is not really a commodity, because it doesn't have any intrinsic value in itself. But some actually said that it was representative money in a way of a gold certificate. The idea of Bitcoin also stemmed from the idea of a gold coin, or some kind of way to actually capture intrinsic value through electronic means. But that's not really what Bitcoin is. It isn't backed by any real asset. Some say it's backed by the people who actually mine and use the network, or the electricity that's put into the network, but I don't really agree. I think Bitcoin is really something special. It is just a cryptocurrency, and that's just what it is. It has no intrinsic value in the sense that we think about it, except that the functionality that it provides in terms of very short transaction times, and also very small fees. So and you can wire money almost instantly anywhere in the world in the matter of seconds or minutes. You can just forget about the idea of waiting until your bank opens on a Monday. You can just do anything you want just on the weekend, for example, or if you have some kind of market that's based on Bitcoin, then it would be actually open at any time, just like the currency market. It's important that you know that there are very different ways to look at Bitcoins, exactly like I illustrated before. In Switzerland, it's been officially considered as a currency, so citizens don't have to pay taxes on gains and on it. So that's a very interesting ruling. They only have to pay taxes on wealth, like they would need to for any asset or anything that they own. In the US, it's considered as a convertible, decentralized virtual currency. So they embrace that idea that it's not really anything like fiat money, commodity, or representative money. It's something different. And so it has its own definition. The rulings might depend from one state to the other, so I'm not qualified to talk about the legal aspect of Bitcoin in the US or in the world, but the regulation aspects might change a lot in the next month and year. So it's something that it's important for you to be aware of and to follow. And just lastly, in Australia, they consider it as an asset and not as a currency. So yeah, it's kind of like having stock in a company, which I think doesn't really make sense, but if some regulators actually have an incentive to see it like this, so or maybe they have some good reason for that. Anyway, so that is Bitcoin. So let's continue. That will get a bit more technical, but I will do it pretty fast. So Bitcoin, as I said, is based on proof of work. So you might see those words: POW, CPU, GPU, ASIC. It's important that you just have heard of them. So proof of work is based on the idea that it's very difficult to forge a block, basically. And the more people are actually mining block or basically creating a consensus over a given blockchain or chain of blocks, then it's much more difficult for an attacker to revert it and falsify it. And even if attackers were able to, let's say, create blocks exactly the way they wanted, they wouldn't be able to steal money. They couldn't just steal money from your account, because only you can actually sign a transaction that concerns your account. So that's not something they could do. What they could do is do double spend attacks, but we'll maybe just look over it later a little bit. So it's about proof of work mining. So some people are incentivized, miners are incentivized to make the network more secure, and they actually get rewarded every time they mine a new block. So at first they only used CPUs, so just normal computers. Then they switched over to graphic cards, so GPUs, and now it's very big in China. They use ASICs, which are specialized hardware just to mine bitcoins. And we'll see later why that might be a problem. And there's this idea of mining pools. So Bitcoin is backed up by a let's say relatively large community, at least 1 million users. It's probably more. And in the future, I mean, it might still increase by quite a bit if Bitcoins can hold its promises, and that's why Ethereum is so exciting. Of course, if you heard about Bitcoins, you probably heard about everything that was bad about it, since I don't think the medias and governments are so, let's say, thrilled at the possibility of having a currency that is independent of central banks. But that's definitely something that's big on Bitcoin. The Silk Road, you actually see it here. So there's like cocaine. I don't know what this is. Those are cigarettes. There's some kind of well, I don't know. That's MDMA. Well, yeah. So that's the kind of stuff you can find on the Silk Road. And the idea is that they use Bitcoins because it's anonymous, kind of. Also has been used for money laundering, theft, and extortion. So those are really bad things that, as an investor, you wouldn't want your investment to be involved in. So mining pools, so that's just what I was talking about here. So mining pools are basically, let's say, domains or websites where miners come together and put their computational power in common so that they can actually generate smoother revenues. But this also leads to centralization issues, and I said double spend before. So I said nobody can actually spend your money, but what could happen is that if you were malicious, if you could control the blockchain, what you could do is spend the money twice. You could send on one transaction the money to yourself, back to yourself, with just another address that you have, and send it to some vendor. And the vendor, if you control the blockchain, you might just create two chains, or there might just be two chains, and one you'll control. One will actually have the right transaction that is to the vendor, and the other one will have actually your own transaction. And when blockchains split, that is called a fork. It's a very important concept. And the vendor will actually receive the money of the transaction, but actually the bitcoins, or the money that it actually has received, will get invalidated later. Of course, this can only happen if you possess at least 51% of the computational power, and even then it might still not be enough. So let's say it's extremely unlikely that it happens. So this is extremely secure. It's just that in cryptography, we'll always think about the worst case scenario to make something secure. In the case of Bitcoin, it's still extremely secure. And if you don't trust someone, then you can just wait longer so that it's absolutely unlikely or almost impossible that they could double spend. Because over time, the likelihood of a double spend just decreases exponentially. So, but that is always a concern with proof of work algorithms. Okay. So far so good. So the problem with mining pools is that they actually make the computational power around Bitcoin to more centralized. If you see only a few actors or a few mining pools have a majority, and if they were to collude, then they could actually make some very big impact in double spend attacks. But if you're a vendor or if you use Bitcoins, then it just depends how much you trust the other person. So from a friend, you don't even need to wait. He will just send you money and some Bitcoins, and over maybe in 5 to 60 seconds you will receive it, and then you know that he's not going to double spend. And even if he wanted to, he would never have the computational power to do that. It would cost millions and millions and maybe even a billion to actually create a double spend attack on Bitcoin. So from a friend, you don't need to worry about it. From someone you don't know, you might, and if it's a small transaction, you might want to wait for one block, so maybe 10 minutes. If it's a very big transaction, you might want to wait for 3 blocks, 30 minutes, or maybe 1 hour. And so it's still much faster than using any other means. And it's much more secure. But that's still an issue that the computational power could be so centralized. So as I said before, it went from CPUs to ASIC miners, which are specialized hardware. And the point of mining is that miners will get rewarded by mining new blocks, and also they will be paid by the transaction fee that people who make transaction include in their transaction, so that miners have an incentive to actually include their transaction, because they might also as well ignore it. The problem is that ASIC miners and some miners have very little incentive to be full nodes. Full nodes means that they have the whole blockchain on their computer. Since it's a public ledger, every transaction that's done is also public, and every node, that every miner, every full node needs to have everything stored. But the problem with Bitcoin is that you can mine without being a full node. And if you look at this picture, those are ASIC miners, so those are just small USB keys, and there are something like 56 of them or something like this, or even maybe more. No, actually there are 70 of them. So there are 70 of them here. So it's absolutely huge, the amount of computational power that it brings, and it would mine much more than any of your graphic cards or CPUs. But the thing is that they don't have the whole blockchain. So if you wanted to, so they're not going to contribute to the network, except that they will mine blocks, but it's still kind of free riding. And that is an issue that is actually, let's say, fairly solved in Ethereum. And also, yeah, the blockchain has grown substantially since the beginning, and as of today, it's more than 50 gigabytes. So that makes it very difficult for anyone to actually be a full node. But of course, you don't need to be a full node. You can just have a light client, and check your account balance or even make transaction. You don't even need to be a full node even need to be a node at all almost for making transaction. You just need to be connected to some node and tell him, I have this transaction. But if you want to check your balance, then you need to know that you need to verify cryptographic proofs that you indeed have the cash that you have, that the person tells you that you have, because he just gives, the computer just gives you some information and you actually need to verify that it's correct. All right. And also a big thing in Bitcoin is the waste of electricity and energy. So if you think about it, 3 gigawatts or 3 gigajoule per second is the amount of energy that's being used in Ireland now. So this is absolutely huge, and of course it's very wasteful, since once it's been used, that electricity cannot be used again, obviously, while that wouldn't necessarily be the case for some other assets where it's not necessarily purely wasted, but in the case of Bitcoin, it is purely wasted. Although it helps make the network more secure, it is definitely an issue, and that also brings some questions about what it could be in the future if it were to grow much bigger. So I don't want to go too much into the bad thing about Bitcoin, because essentially it's a brilliant idea. It really is a brilliant technological invention, but we still need to understand what the things that are wrong with Bitcoin to understand why Ethereum is so exciting and what it really brings, to the table. So there's the block size problem. So essentially, you are talking about the blockchain, and every block has a given size, and since every transaction also has a given size, because it's information, you cannot compress it infinitely, it takes some space. And since the number of blocks per amount of time is also limited, and the block size is limited, then the number of transactions per amount of time is limited. And as of today, I believe that it might be something like 7 transactions a second, which is not too bad, but it's not enough for a network that is supposed to scale. And the problem is that if you don't pay enough transaction fees now, so what I'm talking about is something that's more recent. It's really, those problems have become clear since 2014 or 2015, definitely 2014, and in 2015 it really is clear now that this is a major issue. But if you think about Bitcoin in 2012, that has never been a question or an issue, since there were much less people using it. And so the problem with the block size, a limited block size or too small a block size, is that it forces users to pay much higher transaction fees when a lot of people also want to make a transaction at that time. Obviously, the advantage of the blockchain in Bitcoin is that it's extremely secure and cheap and fast. So we still keep the security property by keeping the block size the way it is, but we definitely lose the fact that it's cheap and fast, since you will need to wait before someone actually includes your transaction into the blockchain, and maybe he doesn't even want to do it, since he might not be incentivized to do it. So what you need is to actually increase the fees that you pay, so that you incentivize him to do it. By him, actually it's going to be a computer, but the owner of the mining pool, of the author of the miner, is actually has incentives. So you by making the transaction fee higher, you can incentivize him to include your transaction block faster. But the problem is that it costs more. So that is a difficult question, and there are very large heated debates about this. And what might even happen is that we experience a hard fork where the Bitcoin community might split, or many different things could happen. And so if some time passed since I recorded this video, probably you should check where Bitcoin is. On the 11th of January 2016, the Bitcoin developers are supposed to come up with a solution by that time. So that is definitely an important issue. Also, regulations might make it difficult. Bernanke, for example, said that Bitcoins had problems. He might not be the worst opponent of Bitcoins. He also said it was interesting, but many governments and regulators are really thinking about Bitcoin and what it means. In Switzerland, they said, well, Bitcoin is too small a market for now to actually be regulated, so they just said it was a currency. In the US and in Australia and in Russia, they have different ideas. So it's always very dependent, and it's also something that might threaten Bitcoin, although since it's decentralized, you can only really regulate the use of Bitcoin through the Bitcoin exchanges. So those companies that actually help you buy or sell Bitcoins. And also by forcing citizens to report or give some personal information if they own Bitcoin. That's something in the same way that it is being done for weapons in the US, for example, where now regulation are a bit more strict, although they're still not very strict to European standards. It's something that might also happen for Bitcoin depending on which direction it goes. And lastly, the problem of centralization, which I already elaborated on before. Okay, so all good. It's good that we've talked about Bitcoins. Let's talk about more exciting stuff now. So why is Ethereum interesting? With Bitcoin, we know that it gives us the opportunity to do transactions all around the world very fast at very low fees, at least in its original form. There are also other currencies that are based on Bitcoin that do that, and that might be a bit faster, like Litecoin or Dogecoin. So that invention, that blockchain technology, enabled that. So why do we need Ethereum? Well, because of smart contracts. Smart contracts are, if you want, an autonomous set of rules that is executed in a decentralized way, and we'll really look into it when we talk more about this. So Ethereum brings smart contracts to the table. Although it's already possible to do some smart contracts on Bitcoin, it's very cumbersome to do. And the thing that might really be game changing is our DAPs. those are decentralized applications, and they actually rely also on smart contracts. We'll look into this later. So there are many technological improvements. So I told you a lot about what was wrong with Bitcoin, although it is still an absolutely amazing technological invention. It has some weaknesses, and Ethereum addresses a lot of them. So first, the issuance model. Well, in that case, you might argue whether it's an improvement or just a design choice. Bitcoin has a fixed supply of Bitcoins, actually 21 million. As of today, there are a bit less than, a bit more, yeah, something like 4.8 million Bitcoin that have been mined on the network. But every year the reward for mining a block actually is every 2 or 4 years, I need to check, is the reward is halved. So now it's 25 Bitcoins per block, and it's gonna be 12.5 and so forth, and it's gonna actually go down until it will still not be zero, but it will almost be zero until it comes to 21 million Bitcoins. And then the network will really rely on transaction fees, but that's still, that is a serious problem that is really addressed in Ethereum. Ethereum uses the same mechanism as of today than Bitcoin, but it's based on reinflation. So every year about 18 million Ether, so Ether are the coin of Ethereum, of the platform. They are the currency, just like dollars, euro, or Bitcoins. So every year about 18 million Ether are being issued or being mined by miners on the network. And this might change. So I'm not gonna go too much into those kind of details and give you too much numbers, since that might change. But the idea is that using that model, the inflation would actually tend towards zero, since the total amount of Ether that are mined every year over the total supply of Ether will just go towards zero. So basically inflation would be almost zero. And that might be a better system, since it still creates incentives for miner to mine even when even in 100 years. But we'll see that this might not matter, since Ethereum is scheduled to switch to proof of stake, which is a very interesting invention as well. So Ethereum has shorter block times. Bitcoin takes about 10 minutes for a transaction to be validated or for a block to be created. And in Ethereum it takes about 17 seconds on average. So that's actually quite interesting, since it makes it faster for you to know whether your transaction has been accepted. And the real thing that differentiates Ethereum from Bitcoin, if you just wanted to say one thing, it's that it features a Turing-complete programming language that actually enables you to write smart contracts or anything that you want. And that is really profound, how far it can go in terms of consequences. So it's much more dynamic and modular. By dynamic, I especially think about the team that is developing Ethereum, but also the modularity of the platform. For example, it doesn't rely on any specific cryptographic algorithm for security. It's written in such a way that everything could be changed, or if you want, the building blocks could actually be replaced and changed, and the whole platform will still work, which is a very important thing to consider, since it is supposed to last for 50, 100 years or even more. It was really built in the idea that it will last long. Object can interact. That is quite profound. What it means, basically, contracts can call other contracts and interact. Don't worry if you don't understand what it means. And also, that's actually one of the real important difference with Bitcoin, is that it's multi-state. It's not something you can do in a decentralized way using Bitcoin. So because the fact that it's Turing complete is really nice, but what's really important is that you can actually hold multiple states. So if you we'll see why later, but that is just a keyword that you can maybe keep in mind. And it's ASIC resistant. That is really important. If you remember, before we saw those mining rigs with all those USB keys, and those were ASIC miners, and Ethereum is actually resistant against them in the sense that it is extremely difficult to produce hardware that would be able to mine Ether without being almost as expensive as a graphic card. So you wouldn't have much gain by doing this, and you also really need to be a full node to mine, and that is really really profound, and that's a much better way to actually look at it. And also, just on the topic of mining, also there is this concept of uncles, where every miner gets rewarded if he basically found a block, even if it ends up not being accepted. But just so that you know, in case you hear that word, it is to become highly scalable. That's why there's an asterisk here. That's what's planned for Ethereum 2.0. There is a new paper. There is a white paper by the founder Vitalik Buterin on scalability, and it is really quite a technical challenge to do. And if they manage to do this, that would make the platform extremely useful and extremely modular, and basically anything almost could be, like, so many things could be built on top of it if they manage to do this. But even just as of today, the number of applications that can be built on top of Ethereum is already mind-boggling. So, and it is to become proof of stake, to switch from proof of work like Bitcoins with miners and the mining rigs and computing crypto challenges using a lot of electricity, from there to using proof of stake, where basically if you are a validator, which is kind of the equivalent of a miner for Bitcoin, for proof of work, if you're a validator, then you sign transactions and you basically put some of your stake on the line, so that people can rely on what you say. Let's keep it at that level. And if you were to lie or be distrustful, then you would actually lose some of what you put on the network. You would lose some of your stake. And if you are honest, then you will be rewarded. So that also means that you need to hold some ether to be able to be a validator, and that is a very important point for investors. So I think that could almost be the topic of a single video. So we'll see in the next video what we can say about this and how it's relevant for you. But as of today, Ethereum still works using proof of work. Proof of stake should come in Ethereum 2.0, but I cannot give any guarantee. So you just need to follow this. So just like Bitcoin's, Ethereum has addresses. So if you want to be able to receive money, you need to have an address. And you also have a private key, which is basically your password. And if someone sends you money, then by using a password, you can sign a transaction to spend it. And when someone sends you money, you can use their public key to verify that what they say is really comes from them. So, but just that you've heard of this. So Ethereum addresses and accounts. So there are two kinds of addresses: regular addresses, like I just told you about, and contracts, smart contracts, which is really the thing that we're gonna look into. Could say everything is a contract, essentially. A regular address is just a contract that has the limited functionality of a safe. And contracts in general leverage the full capability of the Ethereum virtual machine, because as we heard before, it is a platform that basically enables contracts that were programmed using a Turing-complete programming language. Well, those have to be interpreted by something, and that something is the Ethereum virtual machine that every full node actually runs. So if you create a contract, then every full node on the network, once you have deployed it, will actually verify it. Okay, so that starts becoming interesting. So what is a contract? It's an autonomous set of rules. So if you just think about what a contract is in a legal sense, then that's also you would also come with the idea that it's a set of rules. 1.1a, the owner of this contract accept liability for this or this or this. That's how you would actually phrase it. That's really nothing but a set of rules. The idea here is that it is autonomous in the sense that it is actually written in such a way that the computer can verify it. And that is a truly brilliant idea. So as I said, it's written in one of the programming languages that were built for Ethereum, so Serpent and Solidity. And it's also possible to use blocks, which is a more intuitive way to do them, and we'll look at an example here. So they are executed by the platform. So basically every full node actually executes every contract. Impartial, yeah, exactly. So that's good enough. It's validated and enforced by the platform. And what's really important is that you don't need to, if you write a contract, you don't need to worry about the security of the contract, in the sense of you don't need to worry whether the cryptography is correct, or if the network is gonna be up or down, or is it gonna work. You don't need to worry about all those things because they are taken care of by the network. And the security of your contract is taken care of by the platform. It cannot be taken down, and it has very limited requirements. Still, you still need to be a programmer to write contract from A to B. But as a lawyer, by using blocks, you could really write one also very, very easily. And the code is immutable, so that's really important. You cannot change the code of a contract. The code of the contract stays on the blockchain. So if you remember what we said about Bitcoin, we said transactions are put onto the blockchain. Here on Ethereum, basically contracts are put onto the blockchain, and transactions as well. But as we said, basically everything is kind of a contract. Okay, let's see some examples. So maybe you've never programmed before. In that case, don't worry about it. So that's just how it would look if you wanted to create your own coin. The coin using your name, or for if you live in a village, maybe you want some coins for the milk coin. I don't know. Where if you have 1 milk coin, that means that you can buy 1 liter of milk. That could be one example, and you could just create your milk coin just using that code. That's really that simple. You could sell it to someone. Someone could actually pay for it using some other currency, and it would just work like this. But there is something simpler. It's to use blocks, like I told you. In that case, that contract is actually quite a bit more complicated than the one before, but it's actually really visually easy to understand it. So that is a node, basic vote registration contract. Then init, so it's the initialization, and what you see here is the actual instruction. So you could just use the blocks that you see on the left and just put them together just like Legos and build your own contract. So that opens a wide range of possibilities for people who don't even know how to program. For programmers, they have enormous flexibility. Another one that's a bit more complex is a crowdfunding contract, and it is basically an escrow, and so it's something that you could do for founding a project or company or whatever you want, and people could just send some money to the contract, and under some set of rules that you actually defined, you could also use this to do this. But here you really see the detail. Under those set of rules, then you would either the contract would automatically send the money to the recipient if, for example, the goal has been reached, maybe $500,000. Could use dollars or Ether or Bitcoins or whatever currency you want. And if it doesn't work, then everyone would actually get his money back with certainty, which means that you don't need to trust any one person on the network. You don't even need really to trust. I mean, you only need to trust the network, which is secured using by a lot of people that actually contribute to it, so you can rely on that, and also everything is monitored, and so that is really powerful, and everything is automated, so you don't need any third party taking fees, delaying you, censoring you, or none of this makes sense using Ethereum, and that is just one application, but maybe you might already see where this is leading. If you think about it, we saw only 3 contracts. One was one where we created our own coin. There is a TED talk about this where someone said that in the future there will be a lot of tokens or coins or new currencies that are being created for everything. Maybe one for gas, one for the electricity, one that you use for your traveler mileage or whatever. There are actually already a lot of them. In a supermarket, you probably already have that kind of tokens, and if you reach some amount of tokens, then you will actually receive a gift, or maybe you'll be able to buy some goods with them. That is really the same principle, so it's already widely used in the industry, and you can just create that with a few lines of code or just using that interface. And there's even a simpler way to do it. And the vote registration would actually enable democratic processes to be completely transparent. But those are just 3 applications. There are actually many more. So all of this really, that's what you need to understand, relies on smart contracts. So let us go over some of the applications in a general way. So what the Ethereum blockchain and smart contracts enable are custom currencies, as I told you about, those tokens, those coins, those new currencies, but also financial instruments. And there are many of them. It goes really deep. Some call them colored coins. It can also serve as a certificate of ownership of physical devices, and we'll also look into this. It's also possible to use it for domain names. So for example, google.com, when you in your browser, when you type google.com, then your browser doesn't know where to get this information. So what it does is that it actually requests the address, in that case IP address, of google.com to some servers that it already knows, and then once it has this address, it will directly get in touch with Google servers. So that's basically how domain names work, and that's also something that's really important, and extremely complex applications that you could do with that. So that's just a general statement. It's not limited by this list. And you could also create decentralized autonomous organizations. So we'll look into it later. So let's talk about finance, or more generally money-based applications. So first it's going to be used for trading platforms, since the amount of money, the volume of money that is transferred every day from currency to currency is absolutely enormous. And there's always that problem of trust, transaction fees, and of course speed. And a blockchain-based platform could really alleviate those issues and make it seamless for users. You could use it for bonds. As of today, some of the bonds involve more than 10 parties or even more. They can be extremely complex, and they go through so many third parties, or fourth and fifth party if you want, that you lose a lot of margin and you pay a lot of fees because of this. And using the Ethereum blockchain, you can actually remove third parties. So that is absolutely huge. and those kinds of application will give you a hint as to why banks and financial institutions are so curious and interested in blockchain technology, and also why some of the CEOs of big banks have said so many times that the blockchain technology or Bitcoin is useless, or that it's bad, that it should be regulated. It's because also it's really threatening to the business model. But so it's a double-edged sword for them, because on one hand it would make their business much more efficient, but on the other it might also remove them as a third party where they actually make a lot of profit. You can also use it to merge currencies, so that's just just obviously you can do this. For insurance, although that is that might be a bit tricky to do, but that's definitely possible as well. You cannot do it purely on the blockchain, but you could definitely do some mix of them. Something that is really big, and I think that might be one of the things that will really be one of the applications that starts it off, is crowdfunding. Because if you just want to invest if you want to do venture capital in the US, you need to have at least $1 million in assets and something like 200,000 US dollars or even more in revenue per year to be able to invest, to do venture capital. While using those technologies, you could actually do it much more simply and using much less money, so it would make it accessible to many more people to do capital risk, venture capital, or just funding projects you want, or sponsoring, or maybe even donations. All of this could be done in a very transparent manner and automatic without fees and possibility of censorship. Could also definitely do that for stocks, because in a sense stocks are just an asset, and there of course you can represent that information on the blockchain, so you can also do that for stocks. And one of the big things that is also linked to crowdfunding is the escrow capability, where the blockchain could hold funds and only wire them to the right person once there is some kind of agreement or once some kind of condition is fulfilled, so that you don't need to trust a third party that would actually take huge margins or run with your money. So that is a big thing. And something that's also extremely important, and that might be a game changer, are reputation systems. If you think about betting in general, or prediction markets, and in general consensus on events, on history, on anything that is actually relevant, then there are two ways to do it, really. One is to trust an institution, so you could trust a university, Wikipedia, or a government, or the medias, or you could have some kind of decentralized approach where some actors actually have some kind of reputation within the system, and every time they do something truthful, they will be rewarded and be more reputable. And if they do something that is malicious, then the system will actually punish them. How it's done in practice is complicated, but it is something that is definitely possible, and it's also a very big part. And just to mention one name, maybe you heard about Augur, and it's a prediction market. But in this video I don't want to go too much into the specifics, because I don't know if Augur will be there in 3 years. but I'm pretty sure that Ethereum will be there in 3 years and there will be a prediction market, whatever it's called. That's why I want to keep it general. So also certificates, so certificate of ownership for gold, silver, cereals, housing, cars, whatever commodity or real estate. And of course you can transfer and conserve property over the blockchain. So that way you could prove that you own something, or you could transfer property to someone else. And you could do that in a trustless, without needing to trust a third party basis, and you could do that automatically and without fees. And it would be monitored by the network. So if someone so that way you really can trust that if some kind of issue were to happen, then you always have a very clear trace of what happened, since the blockchain technology is really a timestamping system. If you think it really helps, its main capability is to order events, to basically create a consensus over a chain of event. In the case of Bitcoins, it's the chain of transaction in which order they happened. In the case of a blockchain, a more general, let's say, point of view, then it's just ordering events, and that is extremely useful in those cases. Since if you transfer your property to Bob and Bob transfer it to Alice, then you just need to have the history of the blockchain, and you know that what was owned by you and then by Bob is now owned by Alice, and there is a perfect consensus on that. So nobody will say, oh no, actually that's mine. Bob cannot say that, since he actually forfeited ownership of it. So everyone will be able to test it to prove that he actually isn't the owner anymore, but that actually Alice is. So different kind of certificates, birth, diploma, eventually identity. That's also quite difficult, but that's something that could be done. But if we just keep to diplomas and birth certificates, that is something that might be interesting. Like if you think about Eastern European countries, there is and some third world countries, there is a big problem with corruption and counterfeited diplomas. Using the blockchain, you could actually trace whether someone's diploma has actually been signed by a reputable entity, and that would be really big. And for birth certificates, that's also critical, since not only many people don't have bank accounts in third world countries, but they don't even have correct or even at all certificates of birth certificates, and that could be really important. In some cases, people have been refused their own nationality because the birth certificate wasn't correct, or wasn't issued, or just wasn't recognized. So that's a huge problem that could be solved using the blockchain. For domain names, so the problem is that domain names are very centralized. They are distributed in a sense that once a domain name has been registered, like google.com, then every domain name all around the world will actually eventually get that information. Will be able to communicate it. But registration is controlled and managed by the IANA ICANN, and this is centralized and this might not be desirable since it implies censorship and so forth. So Ethereum could implement that, and it's already something that Ethereum can do. Okay, decentralized autonomous organizations. So they are basically, it's basically like a company or an institution, but it's just made of agents, typically not humans, that follow a certain set of rules, and together they create some kind of moral entity, in the same sense that that's actually how you call a company. It's a moral entity. And that could be actually managed through Ethereum, but that's also a bit complicated, but that's something that we could see in the future as well, and that might be really, really big, especially when we think about artificial intelligence. But I'll just leave it like this, but that's also very interesting, and something that probably every investor has heard about, especially in the technological industry, is IoT, Internet of Things. It's estimated, and that is, I've seen less conservative estimates. I've heard something like 30 billions or something like this. It's estimated that 25 billion devices will be connected to the internet by 2020. And what this means is that eventually we'll actually need to have them communicate with each other. They need to be managed, and that's actually a very difficult problem, because you cannot just have one server that controls 3 billion devices. I don't know if there are let's just say 100 million televisions that are connected to the internet. If you need to update them or do some kind of change for the constructor, then it's really difficult to do that over a very centralized platform. So and especially you might need them to interact. So if it's only Sony that needs to update a television, that it might be okay. But if you want your water boiler to be in some fashion linked to your mobile phone, which might be linked to maybe your lights, that's already possible. And as all of those devices will be connected to the internet more and more, you'll need a way to actually manage them. You want to enhance automation, avoid censorship and network errors, and guarantee uptime. And well, obviously you could use the blockchain. All right, so far we've talked about smart contracts, and smart contracts are really the invention that are what make Ethereum so special. But the thing that will really change users' experience are DAPs. So DAPs stand for decentralized applications. So they are a combination of a smart contract, like I told you, that is running on a blockchain, so it's decentralized, and a user interface. So just like you would, just like an interface like the one you use for your internet browser, or or like Gmail that you use to maybe look at your email, or any kind of interface that you use. The idea is that you could have a Gmail, a Uber, a smartphone app, some kind of client some kind of program client that would just run on your computer or on some device that you have, but the backend, the technology behind it, the stuff that is actually being done would be on the blockchain, running a smart contract. So that's the idea of DApps. And the question is, well, will there be a DApp store? In the same way that there is an Apple Store, there is Google Play, where you can actually download smartphone applications for Android phones, and same for Apple smartphones, for the iPhone. So would there be something like this? And the answer is, of course. It's called Mist, but there might be another one. So I don't want to give names since it might change. But the idea is that, yeah, that is really what will make Ethereum usable to normal users. Because as if you've seen so far, then I still guess that you must be still kind of technically inclined to actually be able to understand all of this information or actually follow it. But the idea is that all of this won't be necessary for the normal user. They will only need to understand the interface. So you don't need to understand the economical incentives of Uber, nor how does the GPS location system works in order to use the Uber app. Well, it's really the same way here. So yeah, so that's really a place for innovation. If you think about WhatsApp, Uber, Angry Birds, Instagram, all those applications weren't thought about. Well, the owners of the platform, let's say Google Play or the Apple Store, they never thought of Uber or Angry Birds or Instagram. But they created a platform where people could actually develop their own apps and add them to the system. And that is really, I think, a good analogy to what Ethereum does. Ethereum is a platform that enables developers to create smart contracts and also graphical interface. So together they are DApps. They are what we call DApps. And those can really be anything possible. Anything is possible. But we have just barely scratched the surface. I really try to stay very general in my talk, and I thank you for your attention. So I hope you understood some of what I was talking about. I understand that depending on your background, it might be difficult to understand some of it. The idea is that at least you have heard of those terms, and I think the part about applications hopefully was concrete enough, although general, for you to see what the potential is. And coming next, we'll look at those applications more concretely. So we look at some companies that are being created, startups, projects that are being developed, venture capital opportunities. We'll also think about the notion of value in Ethereum, because if you think about Bitcoin, it's very clear that Bitcoins are for storing value. How well they do it, I think it's fair to say that in the past it was pretty well done. Now if the number of transactions per second becomes too low in comparison to the volume, then it might be a real issue, and the transaction fee might be too high, so some other platform might take over Bitcoin if they don't change if you don't resolve those issues. But what's clear is that Bitcoin has some kind of value, and it's also scarce. So it's very clear that Bitcoin has some kind of value, although I would argue that some of its price is speculation. But some of its price is really because of its concrete applications. And for Ethereum, it's also it's really interesting and difficult to understand exactly where its value comes from the value of Ether. It's clear that all the companies that will use the Ethereum platform, some of them will be very successful, and there are some ways to create very profitable business models around that platform. So I'm sure that some companies will be very successful. So that's also what I'm going to talk about in the next video, and tell you about investment opportunities and how to think about them. But the idea is also, what about ethers themselves? What about the currency that underlies the platform? What are their intrinsic value, and how to think about their price? Should you buy some? And how should you think about this? And I try to give you also a good overview of this, and as well as specific applications. So thank you for attention, and if you want to get in touch or just look at the article that I'm going to publish next to this video, you can go on my website. You can find the slides there, so you can actually have the links, because I gave references to what I wrote. And you probably watched this on YouTube, so this is my YouTube channel. You can subscribe. I'll be posting more videos on the subject, and of course tell me what you think. You can just comment on the comment section below, so that I can know what you want more of, and if there are things that weren't clear or that you just want me to tell you about. So that being said, enjoy. Have a good day and enjoy.